Good evening, Bearcats. This is the Pre-Cal Review, Chapter 9, 3, and 5. I hope you're having, if you're a junior, I hope you're having a good tax week. If you're a senior, I hope that you are having a nice week as well. We've had nice weather. It's cooled off a little bit. So I hope you get a little bit of enjoyment out of that. We do have our test on Friday. You will get a note card, which you should have been given already, and just making sure that you filled out your note card, and more importantly, that you understand what's on the note card and how to use it. So I'm going to go over the things that I would for sure have on my note card, and I would ask that you, if you have not done the review, that you write these things down, and then you stop the video or turn it off and actually work the review, and then go back and look at the video on the things you don't understand. But if you just look at the video, I don't really know that it's going to help you much. We've seen that happen on a couple of tests, so the note card won't save you. It just will help you from having to memorize everything. So we've got, we're talking about geometric series and sequences, and then we're also talking about the binomial theorem. And so the first thing we're going to do is talk about sequences and series for geometrics, and we have three major formulas. So you have for the formula or a specific term, you want to use a sub n equals a sub 1 times the ratio raised to the n minus 1 power. For geometric, for a series, in other words, we're summing things up, for a sum, partial sum, often denoted by the sigma notation, that means sum, or sometimes s sub n for sum. Your formula will be a sub 1 times 1 minus the ratio raised to the n power, all divided by 1 minus the ratio. And that's for summing things up. And then finally we have an infinite sum. That's a sum that goes over. It will approach a limit at some point, but the infinite sum is a sub 1, and I'm going to call it n, but it's also for an infinite sum, and that would be sum. It would be a sub 1 over 1 minus the ratio. Okay, so those are the three geometric equations that you need to know. We need to know Pascal's triangle. So the pattern is 1 and then 1, 1, and then 1. You add the 1, so you get a 2, 1, 1. Add the 1 and 2, you get a 3. 2 and 1, you get a 3, and 1. Start with 1. 1 and 3, you get a 4. 3 and 3, you get a 6. 3 and 1, you get a 4. 1. 1 and 4 is a 5. 4 and 6 a 10. 6 and 4 a 10. 4 and 1 a 5, and 1. I'll do one more row. 1, that would be 6. 5 and 10 is 15. Excuse me. 10 and 10 is 20, then 15, and then 6, and then 1. And it would continue. Now, a couple things you need to know. This is going to help us when we talk about expanding binomials. And the top one row is actually 0, and this is row 1, 2, 3, 4, 5, 6. If you go 2 numbers in, this is the number that tells you the row number, so that's kind of helpful. And then the other thing, the terms are also that way. So this term right here would be your 0 term, your first, your second, your third, your fourth, your fifth, and your sixth term. So, and that's not the next row. Please make sure you know that that is the term number. So these are the row number, and this is your term number. Your term number. The last thing that you're going to want to know is you're going to want to know your binomial coefficient formula, and that is that C equals R n, and sorry, I messed that up. It's C equals, and it's NR. NR. And we want to, that's going to expand our binomial. This is how we find the coefficients only, and that sometimes can be written as n over r. So sometimes you'll see it that way. That's kind of not very good. N over r. Either way, it means that we're going to take the n factorial divided by n minus r factorial times r factorial. All right, and we're going to do some examples of those, and I think that'll help you to see that. So there you go. I will just make sure you have all this written down. Again, I would stop and actually do your review and then come back and check your answers. But this is this information that you're going to need to know. More importantly, you need to know how to use this information. All right, let's move on to our review. Okay, on page 716, problem 50, the first thing we're being asked is it geometric or not? To find out if something is geometric, we're going to take our second term, which would be negative 18 in this case, and divide by the first term, which would be 54. And when we do, we're going to get a negative 1/3. Then we're going to take the third term, which is 6, and divide by the previous term, which is negative 18. And when we do, we're going to get negative 1/3. Then we take the fourth term, which is negative 2, divide by the previous term, 6, and we get negative 1/3. So notice each time our ratio comes out to be negative 1/3. And because it's the same ratio each time, it is geometric. You could say, yes, it is. All right, let's take a look at 52. For 52, we have 1/4, 2 fifths, 3 sixths, and 4 sevenths, and of course this would continue on. Same premise. We're going to take the second term, which is 2 fifths. We're dividing by 1/4, which means we're multiplying by 4/1, which is going to give us 8 fifths. Then we take the third term, which is 3 sixths, and we're going to divide by 2 fifths, which is the same as multiplying by 5 halves. And when we do, we're going to get 15/12. Both divisible by 3, and that would give us 5/4. And we can stop right there. They are not the same, and so no, this is not geometric. All right, so those are the first types of problems that you're going to have. You need to make sure you're reading the instructions on your review so you know what to do when you see what. All right, the next one are going to be problem 53. And we're trying to find the first 5 terms of the sequence. Okay, first 5 terms, that's giving a formula and specific terms, so we're going to use our a sub n equals a sub 1 times the ratio raised to the n minus 1 power. So you have to really know the formula that you're going to choose to use. They give us in this problem, given information, and they give us that a sub 1 is 4, and the ratio is negative 1/4. All right, and we want to find the first 5 terms. So we're going to use this formula. So a sub 1 is, and now we're going to, instead of a sub n, we're going to find a sub 1. The value of a sub 1 is 4. The ratio is negative 1/4. And we're going to raise that to the n, and now n is 1 minus 1 power. 1 minus 1 becomes a 0. Anything with the 0 power is 1, so this whole thing becomes a 1. 1 times 4 is 4, and that is your first term. A sub 2, you get a sub 1, which was 4, our ratio, which is negative 1/4, and we're going to have 2 minus 1, which means we're going to have, this becomes 1. So you have negative 1/4. This whole thing becomes a negative 1/4 times 4, which puts me at negative 1. All right, I see an alternating pattern possibly here. A sub 3, that would be 4, and our ratio is negative 1/4, and it would be 3 minus 1, which becomes a 2. Now be really careful. When you square a negative number, it's going to become a positive. This would become positive 1/16. Times 4 would give me a positive 1/4. Yes, I do think we have developed an alternating sign pattern. This would continue. When you continue, I believe that you're going to get negative 1/16 and positive 1/64. All right, let's move on to problem 54. If you need to slow it down or stop it, please do. Again, same problem, and we're going to use a sub 1 is 2, and our ratio is also 2. We're using that formula a sub n equals a sub 1, r n minus 1 power. So we're using that formula over and over again. Again, not required to memorize, but certainly required to understand how to utilize it. All right, so we're going to substitute in. We want to find term 1, we want to find term 2, we want to find term 3, we want to find term 4, and we want to find term 5. So for term 1, we're going to plug in a sub 1, which we know the value is 2, times the ratio, which is 2, raised to the n minus 1 power, so that would be 1 minus 1, or 0. All right, 2 to the 0 power is 1. 1 times 2 would be 2. Next one, we're going to keep the 2, we're going to keep the ratio, but it's 2 minus 1, which is just 1. 2 to the first power is 2, and then you'd have 2 times 2, which was 4. For the third term, we have 2, the ratio is still 2, except it's going to be 3 minus 1. Okay, so cross that out. 3 minus 1 is 2. We have 2 squared, that becomes a 4, and then 2 times 2 is 8. 2 times 2 is 8. All right, 8 to the fourth. We have 2 again, the ratio is 2. We have 4 minus 1, cross that out, it's the third. Well, 2 to the third power is 8, and 2 times 8 is 16. Now, before I have to go to all that trouble, I do need to see on your test your substitution into your equation and your simplification of that substitution. However, once you do 2 or 3 of those, if there is a very easy, distinct pattern, you could just go on and write the pattern. Look what's happening. It's 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so 16 times 2 would be 32. And that would be your last of the 5 terms. All right, let's move on, Bearcats. Okay, in the next problem, we're asked to write the expression and then find the 20th term. Okay, so the expression and finding a specific term, we're still using our formula a sub n equals a sub 1 r n minus 1 power. So we haven't changed the formula we're using. We have given information's a little bit different. We've given term 1 is 16. That's going to go right here. We've been given term 2, but we don't know the ratio. So we're going to have to find that out. Well, remember, if the first term was 16 and the second term was 8, then we would find the ratio by taking the second term and dividing by the first term, which would give us 1/2. Which would give us 1/2. Now, I have a question for you. Oh, wait a minute. Our given information was a -8. My bad. So I'm going to give it -8. So it's a -1/2. All right, now we're ready to go. So now we have r. This is our r. And we have a sub 1, which is 16. So we have those two pieces of information we can plug in. And so our equation would be a sub n equals 16. I'm sorry, yes, 16. And it would be times the ratio of -1/2 raised to the n minus 1 power. So that would be our expression. Now we want to find the 20th term. So we're going to make n 20. So a sub 20 equals 16 -1/2 raised to the 20 minus 1 or 19. Or 19. And when we calculate a sub 20, we will get a very large decimal or fraction, and you're going to get -1/32,768. So Bearcats, that's your answer. All right. You may need to pause here and make sure you understand so far. We're going to move on. If you decide to pause, though, I'll be right here waiting for you. Okay, on 59, again, similar to what we just did, we're going to write the expression for the nth term and find the 20th term. So we want to write the expression. We'll still be using a sub n equals a sub 1 times the ratio raised to the n minus 1 power. So we have a sub 1 and we have r, so that's pretty simple. So our formula would be a sub n equals a sub 1, which is 100, times the ratio, which is 1.05 raised to the n minus 1 power. That would be 100 minus 1, which is 99th power. Now that's our formula, and now what we want to do is find the 20th term. So we want to find a sub 20. That would be the 100 times the 1.05 raised to the 20 minus, what did I do up here? Sorry, that would be n minus 1. I don't know what I did. 20 minus 1. And 20 minus 1 would be 19. 19. So now I would have 1.05 raised to the 19th power, get an answer, and then multiply that answer by 100. When I do that, I'm going to come out with a very large number. It's going to be approximately 252,695. All right, go Bearcats. All right, this, you notice a little funny symbol, the sigma symbol. That always means to sum things up. And if we're summing things up, we're going to change our formula. So our S sub n formula, or our sigma formula, is going to be the one we used earlier, which is a sub 1. And then it's times, 1 minus r to the n power all over 1 minus r. All right, so we're going to use that to sum things up, and we have to have a sub 1 and r again. So we're needing the same information. We're putting it into a little bit different formula. You have to be very careful. Let's generate our first couple of terms, a sub 1 and a sub 2. So a sub 1, we're going to use this as our rule, so it'll be 2 to the, and this is like an I. So the index here is 1, and the limit is 7, and if you start at 1 and include 1, you're going to have 7 terms, so our n value will be 7, so n will equal 7. A sub 1 is going to be 2, but we're going to find a sub 1. We're going to put 2, and it'll be I, which is 1 minus 1, which is 0, and anything to the 0 power is 1. So a sub 1 is equal to 1. For a sub 2, we're going to have 2, and we're going to have raised to the 2 minus 1 power, which is 1. 2 to the first power is 2. And let's go ahead and find a sub 3. So that will be 2 to the 3 minus 1, which is 2, and 2 times 2, which would be 4. It almost looks like we're doubling our values each time. All right, but we found the first term, which is 1, so we have a sub 1, which is 1, and now we just need r. Well, we have 3 terms. To find r, you take the second term and divide by the first, which is 2, or the third term and divide by the previous, which would be 2. So our ratio is equal to 2. Now we can substitute into the formula. A sub 1 would be 1 times 1 minus our ratio of 2 raised to the 7th power all over 1 minus 2. When we put all of that in our calculator, you're going to end up getting 127. Woohoo, go Bearcats. All right, let's keep going. Okay, I want us to notice in this problem that our index starts at 1, but our limit is at infinity. The sigma does need a sum, but we're going to use the infinite sum formula. I think that's going to be, just make sure that you have that written down in your note card, and that would be the one we wrote down earlier, and I'm going to still call it S sub n, but it's going to be a sub 1 just divided by 1 minus the ratio. So it's a pretty simple formula, but you have to know which one to use when and how to utilize it. Again, we're going to need the first term. To find the first term, we're going to plug in 1 into our I value. So for a sub 1, we're going to find 0.1 raised to the 1 minus 1. 1 minus 1 is 0. Anything to the 0 power is 1. So a sub 1 is 1. So we're going to start plugging in. So we have 1 over 1 minus. All right. Now we need to find the ratio. Well, we have to have 2 terms to find the ratio. So let's find a sub 2. That would be 0.1 raised to the 2 minus 1, which is actually 1. So 0.1 raised to the first is just 0.1, or 1/10. And you will have a calculator, so you could just leave it as 0.1. So you would have 0.1, and then you would go ahead and put that in your calculator. Very carefully put that in your calculator. You're going to end up with 10 ninths. 10 ninths. You want to convert that back to a fraction, and there you go. Go Bearcats. If you're having trouble with that conversion, then just come see me and I'll help remind you. Actually, let's just do it real quick. So you could have 1 over 1 minus, and 0.1 is 1/10. So you really have 1 over 9 tenths. And so that's 1 divided by 9 tenths, which is the same as 1 times 10 ninths, which gives you your 10 ninths. And there you go. Go Bearcats. You pre-cal students, I know, can deal with all those fractions. All right, let's move on to page 670. Okay, on page 670, this is problem 36, and we're asked to find the 7th term. Okay, that is a specific term. So again, you're going to use that original formula, a sub n equals a sub 1 times the ratio raised to the n minus 1 power. All right, and we're given 3 terms here. So we know that a sub 1 is 3. We can find the ratio, so I'm going to just start plugging in. We want the 7th term, so our n value will be 7. So a to the 7th equals a to the 1st, which we know is 3. We've got to find the ratio, and when we raise that, we're going to raise it to the 7 minus 1 power. All right, so the ratio, remember what we did to find the ratio. We take the second term, which is 36, divided by 3, and we get 12. If you want to just double check it, you can take the 432 and divide by 36, and you'll get 12. So your ratio is 12. And so now we're going to find a sub 7 equals 3 times 12 raised to the 6th power. You're going to put that in your calculator. It's going to be a very large number. A sub 7 would be 8,957,952. Woohoo, go Bearcats. All right, let's go on to 38. We're going to find the 22nd term. Wouldn't want to have to list that all out. So I'm going to use my formulas. Again, a specific term, so you will be finding you'll be using a sub n equals a sub 1 times the ratio to the n minus 1 power. All right, here are the sequence they give us is 4, 8, and 16. 4, 8, and 16. So we need a sub 1. We know that's 4. We want to find the 22nd term. That's our n. So we have a sub 22 equals a sub 1, which is 4. We need to find the ratio, and we're going to raise it to the 22nd minus 1 power. All right, so the ratio, we take the second term, 8, divide by the first term, 4, that would be 2. Take the 16, divide by 8, that would be 2. Our ratio is 2. And so we'd have a sub 22 equals 4 times 2 raised to the, and this becomes 21/21st power. And you put all of that in your calculator, and you'll get also a very large number. And the 22nd term is 8,388,608. Woohoo! All right, let's move on. Okay. Problem 62 asks us to find the sum, and we would know that because of this sigma notation. You have to be really careful this time because our index starts at 0. And if we start at 0, then if we start at 1, we would have a limit, our upper bound limit would be at 40, and we'd have 40 terms. But because we start at 0, we actually have 41 terms that we want to total up. So you've got to be really careful. So 41 will be our n value in our formula. So I'm going to go back, and it's we're going to use the sum formula, which is s sub n equals a sub 1 times 1 minus the ratio, which is raised to the n power all over 1 minus the ratio. So that's our formula, and we want to total up 41 terms. We have to be really, really careful. All right, so we're going to do 41 terms. So I'm going to write s sub 41. Our first term, how do we find our terms? We just plug in, starting with our index. We're going to plug in a 0. Anything the 0 power is 1, and 1 times 5 would be 5. So a sub 1 equals 5. We're going to need to find the second term so we can find our ratio. So to do that, you would plug in, you plugged in 0, and now you're going to plug in 1. So 3/5 to the first power times 5 is going to give us 3, so a sub 2 is 3. All right, so that gives us 2 terms to find our ratio with. Our ratio would be the second term divided by our first term, or 3/5 is our ratio. So we have our ratio and our first term, and now we can plug it into our formula. So a sub 1 was 5. We have 1 minus the ratio of 3/5, and 3/5 is raised to the n power, which is 41, all over 1 minus 3/5. Now, this is a little bit of a calculator situation. On your test, everything that you see on the screen right now, you would need to write that on your test. I need to see the substitution to the formula. You can write the formula once on your test if you want, or have it on your note card and not need to write it down, but I do need to see the substitution right here. And then you're going to be really careful. There's a lot of mistakes made on this test by operator error on your calculator, so be very, very, very careful. If you put this in the calculator, you're going to have to put it in with those parentheses. You're going to put 1 minus parentheses 3/5 raised to the 41st power, and then I would enter. Then I would multiply by 5. And then I would divide by, 1 and parentheses again. And so you're going to have to practice this in the calculator. Make sure you're getting the correct answer out of your calculator. It's going to be approximately 12.5 0, 0. But you need to practice in your calculator before you take your test. And I don't mean Friday, right, when you walk in the room to take the test. I mean, you need to come in and practice on the calculator before then to make sure you're getting the right answer out of that calculator. All right, let's move on to 64. Again, we have another summation notation. Our index again is 0. Our upper limit is 20. And we have the rule is 10, 1/5 to the n power. Okay, we know we're going to use that same formula. S sub n equals a sub 1 minus the ratio raised to the n power, all over 1 minus the ratio. So we know we're going to use that formula. We also know from a while ago that our n value will be 21, not 20, because we start at 0. So it'll be S sub 21. We know we can find a sub 1 by plugging in 0 for our n. So we substitute in 0. Either the 0 power is 1, and 1 times 10 would give us 10. So a sub 1 is 10. 1 minus, we need our ratio, but to find the ratio we have to have a second term. So when we plug in our second term, which would actually be plugging in 1, 1/5 to the first is 1/5. 1/5 times 10 would be 2. 2 would be our second term. But to use that term to find the ratio, we would take the second term, 2, divided by 10, which would be 1/5. Notice the correlation there. All right, so 1/5 is our ratio, so I'm going to go 1/5 to the n power, which is 21 this time, all over 1 minus 1/5. Okay, so be really, really careful when you put that in your calculator. You need to practice that, and I also need to see that on your test. You're going to end up with approximately 12.5 or 25 over 2. All right, go Bearcats. Let's move on. Let's look at problem 74. All right, this time we're going to have to write the equation given a sequence. So we're given 7 plus 14 plus 28 plus ... and then plus, or we already have the plus, so 896. So this is our sequence, but notice we're adding things together, so we want a sum. We're going to write a sum, and we're going to use summation notation, which is the funny little e or sigma. And our index, we're going to start at 1, so we're going to say n is equal to 1. And we're going to go up to what term number? Well, this is the term number. This is term 1, a sub 1, 2, 3. We don't know, and we don't know what this one is. So let's see if we can find the ratio. The ratio, remember, is the second term, which was 14, divided by the first term, which is 7, which is 2. So our ratio is 2. So 2 times 14 is 28. So 2 times 28 would be 56. And 2 times 56 would be 112. And 2 times 112 would be 224. 224 times 2 would be 448. And 448 divided by, or times 2 would be 896. Let's count the terms. That's the third. This would be the fourth. This would be your fifth. This would be your sixth. This would be seventh. This makes 896 your eighth term. So our upper limit would be 8. All right, now we could find this another way. Let's talk about how we could find it. If we have the first term and the last term, but we don't know our n value, we could go through and algebraically find that. We'll take a look at that. If you want to go through and do that, come in and we'll do that together. I'll do that with you. All right, in the meantime, let's go back to finding this out. All right, so and on my written out work, you'll see finding the number of terms algebraically as well. And we're using the same formula to find those. So take a look at that. That might help you. But right now we have our ratio. We have that. We're just going to write the rule. Well, the rule we're going to use is our little a to find a term is a sub 1 times r, to the n minus 1 power. So that's our little rule we're going to use, and we're going to kind of plug that in based on what we know. Well, a sub 1 is 7. Our ratio is 2. And n minus 1 power, we're just going to write n minus 1 power. And you could leave it just like that, or we could have put a parenthesis around the 2 and not around the 7, whichever one you prefer, or around both. So that's our sigma notation, and that's all you had to do on that problem. But you need to read the directions to make sure you understand what the directions are asking you so that you don't make that mistake on your test. All right, 2 more of these and we'll go to binomial theorem. Let's do problem 80. All right, this time we have sigma notation, and we have n starting at 0 but ending at infinity. Infinite sum. So 2 2/3 to the n power. And we want to find the infinite sum. So this time our sums are really easy when it's a sub 1 over 1 minus r. It's a really easy equation. So a sub 1 we're going to find by plugging in the 0. I think the 0 power, remember, is 1, and 1 times 2 would be 2. So a sub 1 is 2. 1 minus the ratio. Well, to find the ratio, we need a second term. So we're going to plug in a 1. And we have 2/3 to the first power is 2/3. 2/3 times 2 would be 4/3. All right, now we have 4/3 as our second term. We want the ratio. The ratio would be the second term, or 4/3, divided by the first term, which is 2 over 1. And remember our algebra, we could do 4/3, and instead of dividing, multiply by 1 over 2, which gives us, we can cross cancel that with that, and that ends up with 2/3 equals our ratio. So 1 minus 2/3. 1 minus 2/3. All right, when we put all that in our calculator, then we're going to get 6. Again, you're going to have to practice going from this to this, because that's where many of the careless mistakes are made. Please make sure you come in and practice. I'm here before school. I'm here after school. Do not wait until you walk in the door that day. You will make careless mistakes and miss points. So please make sure you come in and practice. For my students, I won't see you until Friday, so I need you to come in and practice on a calculator, please. All right, let's go on to 82. Again, another infinity summation. So we have n equals 0 to infinity. Rule is 2 negative 2/3 to the n power. And again, we're going to use that same little rule. S sub n equals a sub 1 over 1 minus the ratio. All right, so here we go. Let's find a sub 1. We're going to plug in the 0. We found anything as 0 is 1. 1 times 2 would be 2. So 2 would be our answer. We have to find the second term to be able to find the ratio. So to find the second term, we're going to plug in a 1. And negative 2/3 to the first is negative 2/3 times 2, which is negative 4/3. And now, once again, we got to go through the whole scenario to find the ratio. So the ratio is going to be the second term, negative 4/3, divided by 2, or multiplied by 1/2, which is going to be negative 4/6, which is really negative 2/3. That's our ratio. So we have 1 minus negative 2/3. Minus a negative, that's plus a positive. Be really careful. So that's going to be 5/3. So 2 divided by 5/3 are 2 times 3/5. You can do all that, or you have a calculator, and in your you should be able to get out of your calculator 6/5. Now, you won't have a graphing calculator. You only have a blue calculator. That makes it a little trickier. So let's go through the math for this. This would be 2 divided by, and I'm going to put a parentheses, 1 plus 2/3. Well, you know 1 is really the same as 3/3. So you really have 2 divided by 3 plus 2 is 5/3. So you really have 2 times 3/5. I'm going to put 2 over 1 and multiply straight across. 2 times 3 is 6/5. And there is that answer. So if you need to do it by hand, that's how you can. You'll have a blue calculator to assist you, but not a graphing calculator. All right, let's move on, Bearcats, to binomial coefficients and binomial theorem. All right, if you look back at your notes from the beginning or your note card and see the use of the binomial theorem, and we're going to use that to find a coefficient. Just straight out calculate the binomial coefficient. What would be the number in front of this term? And what you're really finding here is you're finding the fourth term in the 6th row. So you're finding the 4th term in the 6th row. So when it says C6, 4, this is the 6th row, and this is the 4th term. And remember, the terms start with 0 and the rows start with 0. So it's actually technically 7 rows down if you're counting 0 as the first one, and it's actually 5 terms in because the first one is term 0. Remember that. That can be kind of tricky if you were using Pascal's triangle. All right, if you were using Pascal's triangle. And we're going to do that on one in a minute to take a look at it. But let's just use the formula. The formula is n factorial, and remember the 6 is going to be our n and the 4 is going to be our r. So it's n factorial, or 6 factorial in this case, over n minus r, or 6 minus 4 factorial, times r, or 4 in this case, factorial. All right, remember how we did this? We've done this a few times. If not, you can go back and look at the video for this. This would be, let's go ahead and just write this, simplify this, would be 6 factorial, and 6 minus 4 would be 2 factorial times 4 factorial. So now we're simplifying. We're going to go, factorial is just a multiplication, moving down by one integer, so 6 times 5 times 4, and I'm going to stop there because that you can write as 4 factorial. It would be 3, 2, 1. And on the bottom we have 2 factorial and 4 factorial. So the 4 factorials will cancel. So now you really have 6 times 5 and you have 2 times 1. Let's make a cross cancellation. 2 goes into 6 3 times, 2 goes into 2, 1. 1 times 1 in the bottom is 1. 3 times 5 at the top is 15. And 15 would be your answer. All right, let's do another one of those. 97. Again, we have C, row 8, term 5, which would really be the 9th row down, and the 6th term in. Let's take a look at, this would be our n, and this would be our r. So we have n factorial, or 8 factorial, over 8 minus 5 factorial times 5 factorial. All right, here we go, Bearcats. So at the bottom we have, or at the top we have 8 factorial. 8 minus 5 is 3 factorial times 5 factorial. So we're going to have 8 times 7 times 6 times 5. I'm going to stop, 5 factorial over 3 factorial, 5 factorial. 5s are out. Now we have 8 times 7 times 6, and at the bottom we have 3 times 2 times 1. Let's see what cancellations we can make. Well, I see a 3 can go to 1, and 3 goes into there twice. I see a 2 can go to 1, and 2 goes into 8, 4. And we're left with 4 times 7 times 2, and 4 times 7 times 2 would give us 56. That would be the number, or the coefficient, in front of the term that is on the, the 5th term that is on the 8th row. And technically in the triangle, that would be on the 9 little row down, and the 6th term inside your triangle. All right, Bearcats, let's look at that triangle in the next problem. Number 99. We are almost getting there. So we're going to put this in a little different terms. 7 over 3. Same notation. It's equivalent to 7 C3. It's a combination. You want the 3rd term in the 7th row. All right. Now, our answer, if we go through the binomial, the factorial, the 7 factorial over 7 minus 3 factorial times 3 factorial. Let's go ahead and do that. That would be 7 factorial over 4 factorial, 3 factorial. That would be 7 times 6 times 5 times 4 factorial over 4 factorial times 3 factorial. The 4s would go out. 7 times 6 over 3 times 2 times 1. All right, the 2 would go here. Cross this out, becomes a 3. In the bottom, you have a 3. In the top, you would have, times 5. Sorry. Sorry about that. You would have a 3, then you have this 3 to cancel, and 5 times 7 is 35. Now, I want to prove to you that that really is on the 7th row down, or actually 8 rows down on the triangle, because the top row is 0, and it's really the 4th term in because the terms start with 0. Let's do our triangle and prove that that's how you could find it. This is a little bit easier when you're dealing with these numbers, but you could find it Pascal. So here we go. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Okay, let's see what row we're on. So this was row 0, 1, 2, 3, oops, 4. I did that terrible. Let's erase that. I don't like that. Okay, sorry about that. Got kind of sloppy. All right, so row 1, 2, 0. Sorry, I knew there was something wrong. 0, 1, 2, 3, 4, 5, 6. And what do I really need? I need row 7, which is really, if you counted from 1, it would be 8 down. So that would be 1, 6. That would be 21. That would be 35. That would be 21. Sorry, that would be 35 again. 21, 6, 7. Sorry, not 6. It would be 7. That would be 7, 6, and 1, and 1. All right, so there's my 7th row, and I want the third term, which is really, if you count this as term 0, 1, 2, 3, then that makes my third term 35. There it is on our triangle. Wow, it's magical. All right, one last problem, number 105, and we are done for the evening. All right, 105, and we're going to do a binomial. We're going to use a theorem to expand the binomial, and I'm going to do it with letters, which I know will make you really happy. A equals 3b to the 5th power. So we want a fifth row of the triangle will give us our coefficients. And if you want a lot of coefficients, it's easier than trying to figure out each one. So I'm going to create that triangle one more time. 1, 1, 1. Well, first I'm going to find, this is row 0, 1, 2, 3, 4, 5. So I'm going to wonder about this row. All right, so 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. All right, so those are my coefficients. So I'm going to list those out. I'm going to circle them because I think it makes it easier for me visually. So that's a coefficient 1. I have a coefficient of 5. I have a coefficient of 10. I have another coefficient of 10. I have a coefficient of 5. I have a coefficient of 1. All right, now, the first thing I see is negatives, so it's going to alternate sign pattern in just a minute. The next thing I'm going to do is take my, this is a pattern, take my first variable, the first term, and I'm going to go a to the 5th power, a to the 5th power. So a to the 5th power. And then I'm going to decrease by 1, a to the 4th, a to the 3rd, a squared, a, and I don't have an a at the end. Then I'm going to take my second term, 3b, and I'm going to start with no term, and then I'm going to go upward. So this is going to be parentheses 3b to the 1st, parentheses 3b squared, 3b to the 3rd, 3b to the 4th, and 3b to the 5th. And you could have started at the end and gone down if that helps you. All right, and we have our coefficients. Now we need to alternate our signs. Alternating signs starts with a negative subtraction because of subtraction, so subtraction. This will be addition. This will be subtraction, addition, and then subtraction. All right, now we just got to total everything up, and this is where you need to be really, really careful. This is 1 times a to the 5th, which is just a to the 5th, and then we got a subtraction. On this one, we have 5, a to the 4th, 3 to the 1st is 3, and b to the 1st is b. So we've got 5 times 3 is 15, a to the 4th, b. And then we've got our plus sign. And here we've got 10, a to the 3rd, we've got b, or 3 squared, and b squared. 3 squared is 9. So 9 times 10 is 90, a cubed, b squared. One other thing about this pattern, make sure that the coefficients of your terms add up to the power. So 4 and 1 is 5. That's 5. 3 and 2 is 5. That kind of is a check on you, a cross check on that you're doing the right thing. All right, we have a subtraction sign. Okay, here we have 10. We have a squared. We have 3 cubed, and we have b cubed. Well, 3 cubed is going to be 27 times 10 is 270. And then we have a squared, b cubed. Remember, 2 and 3 is 5. I think we're in good shape. All right, now we're going down. So we're going to have plus. We're going to have 5. And we have a to the 1st. This is 3 to the 4th power and b to the 4th power. When you calculate 3 to the 4th power times 5, you're going to get 405. Again, something you've got to be really careful about. 405, a to the 1st, b to the 4th. And finally, you're going to have 1 times, so you're going to have 3 to the 5th and b to the 5th. 3 to the 5th power is 243, and then you have b to the 5th. Now you've expanded. Can you imagine if you had to multiply all of this out 5 times together, how long it would take you. This is so much quicker, but you do have to, it's very tedious, and you have to be very careful in your work. All right, I will be here Monday or Friday morning early before school. You can catch me in the morning before school, or maybe even possibly after school tomorrow on Thursday. But make sure that you've gone through review and get your questions. And, of course, you can call me on the phone. All right, so have a good night. Night, Bearcats.